So here I have my derivative. Now part B asks for the second derivative equaling to 0. Before I do that, I'm going to simplify this a little bit. I can see that I can get a common denominator of x squared plus 4 squared by multiplying this first term by x squared plus 4 on the numerator and denominator. When I do that, I get this is my denominator. My numerator will become 2x cubed plus 8x. I still have this minus, and here I have minus 2x cubed minus 8x. So the 2x cubes will cancel out, leaving behind plus 8x minus negative 8x, which is 16x over x cubed plus 4 squared. So now I can calculate my derivative a lot easier. So it's p not f, p double prime of x will equal to derivative of the top, which is 16 times x squared, this should be a squared, plus 4 to the negative 2, minus 16x from the top, times this negative 2. Actually, this negative is already there, so that's why it's negative 2 times x squared plus 4 to the negative 3 now, times my derivative of the inside, which is 2x. So simplifying this, I get 16 over x squared plus 4 squared minus 16 times 2 is 64. And I have x and x, so x squared over x squared plus 4 cubed. Now I want this all to equal 0, so what I'm going to do is I'll bring this over to the other side, and I get 16 over x squared plus 4 squared is equal to 64x squared over x squared plus 4 now cubed. Now the 16 and the 64 can cancel out, leaving me with just 4. And 3 here and 2 here, so these disappear and this becomes just 1. Cross multiplying up, I get 1 times x squared plus 4 is going to equal to 4x squared. Simplifying, bringing these over to the other side, I get 0 is equal to 3x squared minus 4. This is sort of an odd difference of squares, but I'm going to get square root of 3x minus 2 times the square root of 3x plus 2, meaning x is equal to plus or minus the square root of 2 over the square root of 3, which if you want you can write as plus or minus 2 root 3 over 3. Now I need to figure out what p of those values are. So p of 2 root 3 over 3, plug that into the original function, you get negative 1/2. And actually for the exact same thing, because it is a symmetrical situation, I get p of negative 2 root 3 over 3. That also equals negative 1/2. So my 2 points are 2 root 3 over 3 comma 1/2, negative 1/2. And of course the other point is negative 2 root 3 over 3 comma negative 1/2.